How's lunch? Good, good. Well, we're going to go ahead and get started. We have a very, I know they're hungry. We're going to have a very short but very, very important keynote this afternoon. We've talked a lot about mobility and the security of mobility and the importance of it. But all of our discussions have really been focused on the devices and the data. And while that's critical, one important piece to the puzzle is infrastructure. So we have with us Ross Manier, who's the chairman and CEO and founder, I just found out, of Exonet Systems, Inc. Ross has more than 30 years of business management, finance, and leadership experience for the company. In January of 2010, Exonet business base, opportunity set, and project backlog attracted $128 million in venture funding to support the now emerging growth company, led by SSP Offshore LLC, SBA Communications Corporation, and the existing investors. The funding supports the next phase of Exonet's growth. So with that, I'm going to hand it off to Ross to close it out for the session.
Thanks, Brian. Thank you. We're in the home stretch here, guys, so I'll try to be pretty quick with my comments here, and certainly will entertain any questions you may have about what I'm going to talk about. As Parham said, a lot of the discussion over the last couple of days has been about the mobile device side of mobility, and what I'm going to talk about is the infrastructure that's needed in order to support the productivity and efficiency that's promised by mobility. Okay, and then I'm going to talk a little bit about security from an infrastructure perspective versus from the device perspective. Okay, because I know security is on everybody's mind when we're talking about the mobile environment. Okay. So let me give you a little context from which my remarks are derived. Exonet Systems is what we call a distributed networking company, and what that means in a nutshell is that we build alternative networks to the traditional cell towers that you see all over the place that is providing coverage for your cell phones. Okay? So this new architecture is being driven by this onslaught of all these data applications that are coming on these devices that we used to call phones. And I'm going to describe this network architecture in a little bit more detail in a second. We have built commercial systems now for all the wireless carriers in about 45 or 50 communities across North America. Our largest network, interestingly enough, is in Montreal. It covers almost the entire island of Montreal. We also do indoor systems, which I know are going to be important for many of you. Our largest indoor system is Sears Tower in Chicago, or what's now called Willis Tower, using some patented technology that we have that utilizes the HVAC ductwork that acts as an RF waveguide to propagate that signal through a building. So it's a much more efficient approach to delivering the RF signal in a building. And we've recently started a federal government initiative, as you know, we're here. And we currently manage systems for the Library of Congress and the Securities and Exchange Commission, and we just completed a successful trial of what we call our Intelligent Integrated Distributed Network Architecture, which is the security element in a wireless network that I'll talk about later. And we did that down at Langley Air Force Base for DoD. So let me talk a little bit about our perspective of the evolution of the mobile network environment. As most of you know, the picture on the left-hand side of that slide, which is a traditional cell tower. Antenna arrays placed at the top of the tower, and the carriers will place all of their RF devices down at the base of that tower. And that's the way networks have been built for years and years and years, including doing rooftop-type antenna arrays as well. What's happened with this onslaught of data applications is a need and a desire to actually get the RF source closer to the user to improve network performance and network throughput. So that's caused a migration from the traditional macrocellular infrastructure to what we call the small cell architecture or distributed antenna systems. There are lots of different terminology used in this environment, but that's what's depicted, and it's a little hard to see on the right-hand side of that slide. What that is showing you is an outdoor network, a distributed architecture where we have an antenna that is a multi-band antenna sitting at the top of that street light, and further down on the pole, connected with coax cable, is what we call a remote radio head. And that remote radio head is then connected by a fiber optic cable to a central location where all the radio devices for the carriers are located. And what's interesting about this technology is that it's what we call a neutral host environment, meaning that we can run all the carriers on one single infrastructure and all of their technologies on one single infrastructure. And we can do this both indoors as well as outdoors. So when you hear the term neutral host, what's happened in today's environment is the architecture is now moved where the carrier is owned and managed the infrastructure in a macro environment to more third-party hosts managing the network. So in our particular case, we'll put up our capital, we'll build the network, we'll own the network, we'll manage the network, and we'll upgrade the network as technology changes. And again, we can run all technologies and all carriers on the same infrastructure, whether it's indoor or outdoor. And then finally, because it is a distributed architecture, we can address the needs for the enterprise in addition to the needs of the carrier in that kind of environment. So what's driving all this? This is not new news to any of you, I'm sure. It's the device. These things we used to call a phone are really data terminals. I mean, I watch my kids use these things to watch TV, YouTube videos, movies, things I'm not sure I would do, but certainly the younger generation is doing this, and your workforce is going to be using these devices in a similar manner. And what that has done is created a huge oversubscription of the existing wireless infrastructure trying to support all of these data applications. So if you look at some of the statistics that are out there, in the last 4 years, data traffic on these networks has doubled every year for 4 years. And it's projected to grow at a 78% compounded rate over the next 5 years. We can debate how accurate that forecast is. I could even make a case that it's probably conservative based on what we're seeing from a device perspective and what's going on out in the network. In addition, the second thing that's going on in our environment today is wireline replacement. For those of you who have older kids who are in college, in a dorm room, have an apartment, live at home, I would surmise that most of them don't have a wireline phone. I know mine don't. And so the only way you're going to get in touch with them is to call them on that mobile device, okay? Again, this is the workforce that's coming through. They want anytime, anywhere access with that mobile device. And this is a chart of what's happening in the workplace, okay? The typical worker in today's environment is not necessarily attached to their desk. And this, I think this chart came from a 2006 GSA study, and I read a more recent study in 2011 that said that on average across commercial enterprises and government enterprises, about 35% to 50% is the amount of utilization of the workspace. So if you think about that in the context of trying to derive these productivity and efficiencies out of your workforce, the mobile environment is here to stay. Okay, and I would also postulate that you can save a lot of money if you start looking at reducing the amount of investment you're making in your fixed wireline infrastructure, because it's not going to be needed as much and it won't be as useful to your workforce going forward. So what's happening today? So in prior years, what we would do is we would use that macro cellular network, that outdoor network, to blast RF energy into buildings to provide coverage indoors. Sometimes worked reasonably well in certain environments, and it worked okay when you're talking about making a phone call, okay? But when you start talking about what's happening from a data perspective, in essence what's happening is it's caused an effective shrinkage of that cell radii from that tower. So where I used to get RF energy into the building to make a phone call, that cell radii is shrunk because it's trying to serve all those subscribers outside around that tower. So you couple that with also the need for your subscriber in a building who wants data application and therefore needs more RF energy in order to push through that data. Now you need to extend that network, and the way you extend that network is what we call distributed antenna systems or small cell architecture, which is what we build indoors and on campuses and in communities as well where you can't get a cell tower. And we also talk about this in the context of this open architecture. And why is that important? Well, unless you've decided you want to focus on one type of technology and one carrier and their types of devices, we like to talk about it in an open context, meaning we can support all carriers and all technologies on that single network infrastructure. So, as we've talked over the last couple of days about the mobile devices are driving the network design and the network needs, another element of that is going to be the security component of this. Okay, and in just a minute I'll talk about how we try to address that. Again, I'm not going to sit here and tell you that it's necessarily a silver bullet for all the security concerns you may have from a mobility environment perspective, but it does help solve some of these concerns. So we talk about this distributed network architecture. We talk about both indoor and outdoor, all types of facilities, campuses, bases that these networks can be built, and it provides what we call an RF envelope. Okay, which means it provides the dominant signal for that building, that environment, or that campus. And as I said, we can drive multiple technologies, whether it's distributed antenna systems, it's our DNA architecture, it's Wi-Fi. We can support Wi-Fi on these platforms, picocells, femtocells, microcells, all the various hardware that we have now in the wireless environment. And again, from a neutral host perspective, we can build, manage, own, operate these networks on behalf of you, the customer, which is what we're doing in the commercial environment as well, and also ensure that that network stays up to date from a technological perspective and meets service level requirements for your constituency. So I won't go through all of these advantages that we see in this distributed network architecture. I would highlight a couple of things, though. I'm sure all of you have heard a lot of the news that's out there today about the wireless carriers saying, I need more spectrum, because these data applications are absolutely killing my network. Well, one of the really interesting things about the distributed network architecture is that it is a much more efficient utilization of that spectrum. Think of it as massive cell splitting, which is how a carrier reuses that frequency band multiple times in the same environment. So this is doing massive cell splitting, but in a small cell architecture in order to reuse that same spectrum over and over again, so you're getting a lot more capacity out of that same infrastructure. So it's a real advantage to the architecture as you look at this going forward. The other thing that happens is that you lower that RF source closer to the user, and it reduces the amount of interference that you normally experience in an RF environment. And what that does is improves the performance of the network, improves your data throughput in that environment. So let me talk very briefly here about security. And again, this is talking about security at the network level, not at the device level. I've heard lots of presentations here the last couple of days where we're talking about encryption protocols, different things that we're doing with the device to help secure the data that you all need to secure. I'm talking about it at the network level now, okay? And this is what we call our intelligent, integrated, distributed network architecture, and that is providing a solution where you, as the agency or the owner of a venue, can actually monitor what is going on in that network environment, similar to the way you would monitor your wireline networks. It gives you the ability to manage the activity in that environment. If you have abnormal events, you can react to it. You can capture data. You get all the call log information historically, so you really know what's happening in the context of this environment. In addition, it will give you the ability to control who has access. So if you have an area where you only want certain people to be able to utilize a mobile device in that environment, we can actually give you the ability to control who has access to utilizing that network. And then, in the event of an emergency, if there are certain people that have to have priority status within that network and be able to make a connection and communicate, you can prioritize in the context of this environment and say, okay, these 50 people get priority access. If I'm on the network and I don't have priority access and somebody with priority access calls into the network, I get dropped. And that way you ensure you have a robust infrastructure in the event you have an emergency in which you want to prioritize who has access, okay? And this is, again, what we call the Intelligent Integrated Distributed Network Architecture, and that's what's depicted at a very high level on the slide up here now. So if you think about the wireless envelope or the wireless environment as depicted by that cloud, we built a distributed network in that environment over there, but instead of connecting that network back to a traditional carrier BTS, what we've done is we've connected it back to this IDNA gateway, which if very roughly think about in the context is a network in a box. And this is the device that gives you the ability to control access and to monitor what's happening in the confines of that particular network. And it's all IP based, and so you can control what goes out to the internet, what stays intranet, and if you lose connectivity to the outdoor wireless network, you still have a network that will work, okay? And it's a server-based IP platform that we install in that network. Now, not all environments need this kind of infrastructure, in which case we do what we call a coverage and capacity solution, which is a traditional deployment of the distributed architecture, which is what we're doing commercially out in numerous communities and numerous buildings. So when we talk about a business model associated with what we do, we talk about it as infrastructure as a service, which means we want all the constituencies participating in this network. So it's not just the federal government buying the network, owning the network, and spending the money to maintain and operate that network. We're saying we'll do that as a neutral host provider. We'll hopefully get the carriers to participate as well. They'll make contributions to the operation of that network, and then you will make a contribution as well, so that it's a much more efficient utilization of capital to deploy this network throughout your particular environment. So when you hear the term infrastructure as a service, that's what we're talking about, okay? And it encompasses service level agreements, NOC monitoring, upgrades, preventative maintenance. That's all part of what's included in that business model, okay? So finally, mobility's here to stay. It's not going away. We've got to figure out a way to address this. How do we handle it? How do we deal with the security issues here? We believe small cell architecture is going to become an increasingly important part of that overall network topology going forward. And you're going to see a lot more discussed about that in the future as these networks continue to evolve and continue to get built. And we do believe that there are some solutions out there that can help add another element to your security issues by providing something like an IDNA type solution at the network level while you're also working at the device level. So with that, hopefully I got you through this pretty quickly, and if you have any questions, I'm certainly more than happy to answer. Nothing? Okay.
I got one just on the procurement side. The challenges that we face with respect to, you talked about the shared cost model, and government's got these shrinking budgets. Just really speak to that, because I know that a culture change has to change from the procurement side. But these guys, as advocates for a solution like this, need to understand the challenges that we're facing.
Yeah, one of the things we've obviously been in a lot of discussions with procurement on this, and if we're going to make that capital bet, I mean, we're going to put up our capital, build these networks, we certainly would like to have a long-term contract, okay? And to talk about that in the context where procurement is usually talking about this in terms of annual cycles, we need to change that mindset to say, look, we need long-term type throws here in order to support what we're trying to do. Because for us to go ahead and make that capital bet and throw the capital out there to build these networks, we'd like to be there for a little while. So.
Any other questions?
Okay.
All right. Ross, thank you very much. And that brings us to a close for the program. The final thing we have to do is the raffle drawing. So first of all, has everyone submitted their surveys and the passports and gotten your tickets? All right. No takers? Oh, there we go. One more. All right.